Hey, my dear NEET warriors, welcome to the Collisions and Momentum chapter. This is your one-shot conquer batch where I'm going to teach you right from the basics, tell you the theory, tell you how the formulas are used, how to apply them, and build up that level of confidence so that you can start solving problems, which is what is needed at the end of the day when you want to crack the NEET examination. Isn't that right? Because what are we all studying for? To become a doctor, to become a medical science, person, to practice medicine, or to do something really great in life. And for that, the first step is to crack NEET. And to crack NEET, we need to do each and every chapter in detail. So that's why we have the NEET Conquer batch. And this is your captain, your physics educator, Shreyas, right? Hello Subhashni, Govinda, nice to see all of you. Hello SR Devalni, hello Akansha, welcome Kanak, welcome man, welcome Alidam, welcome. Good evening my dear warriors. So in today's lecture, what we are going to study, I will tell you all the topics. The first one is we are going to see about momentum, impulse, and average force. We are going to see about this. Then we are going to see the law of conservation of momentum, law of conservation of your momentum. Then we are going to see some questions on collisions and explosions. We are also going to see the three different types of collisions, and we will end the class with collisions in 2D. Collisions in basically 2 dimension. So these are the things that we'll be covering. Obviously, the types of collision will also involve the concept of coefficient of restitution. We are going to see that also, coefficient of restitution. So all these things we are going to see in today's lecture. So basically complete coverage in detail right from basics, but in a limited amount of time, right? So the lecture is going to be very efficient, very power packed. And guys, if you want more classes from me on the platform, the entire complete NEET syllabus in detail with everything, every smallest of the smallest thing you want to know, guys, we have the Avenger batch opening right now, 3.0. Last opening, 25% syllabus is remaining. You will be seeing, studying everything live under me and the entire Avengers team. And the entire 75% portion which I have taught and the others have taught will be available in the recorded form, so you don't miss anything, right? So make the best use of this opportunity for enrolling yourself in the Avenger 3.0 batch. It's for a very discounted rate when you use the coupon code CAPTAIN, just like my name, Captain. So Captain is the coupon code. And if you're interested in the test series, that is also available to you. So if you want the offline experience of writing the test series, then you have this one for 4499 rupees. Mock tests with the results, analysis, and also there are 16 number of tests which are made by the educators themselves, and you will get to know your all India rank positioning, where you stand at this point of time, which is exactly what you need. And you might be enrolled in one test series, but let me tell you, most of the NEET students enroll in more than one test series. So you should definitely consider that. If you want, you can get the online experience also. So that is for a little bit lesser price for 2,999 rupees. Again, use the coupon code CAPTAIN to avail these discounts. Remember that, right? So let's begin with the class. Hello Sarath, hello Nandini, good evening everyone. Thank you for all the love from Kashmir. And somebody is already from the Avenger 3.0. Nice to see you, brother. Nice to see you, my dear students. Very good. Awesome. I'll be doing ray optics later on, okay? I'll be definitely taking it up. Maybe we'll see, maybe next week or something after rotation. Right. So let's start. See, if there is a Pandu and he is running, Pandu's mass is m, Pandu's velocity is v, then the effect of mass and momentum is mass and velocity is called as momentum. So I can say Pandu has mass and velocity. So basically he has momentum. And the formula for momentum is as follows. momentum symbol is P. It is nothing but mass into velocity, but momentum is a vector in the direction of the velocity. So that is your momentum, my dear warriors. Momentum is mass into velocity. Obviously, the unit of momentum is nothing but, you can see this is kg. Velocity is nothing but meters per second. So the unit is kg meter per second. It is a vector. It is a vector in the direction of the velocity. In the direction of velocity. So in this case, Pandu has a momentum like this. Pandu has a momentum towards the right side because he is moving towards the right side. If he is not moving, he has no momentum at all. And momentum, we know that we experience this even while studying for NEET. Imagine you're studying very seriously today and then you take a break. Maybe you go for a vacation, maybe there was a wedding, maybe there was some party, maybe there was some break that you took for 2-3 days. After you come back, don't you feel that resistance to study? You feel that all the momentum has been lost. You had gathered a lot of momentum for studying just because you took a break. It takes some time, maybe a day or two, for you to gather that pace. Agree or disagree? How many of you have felt that? How many of you have felt that, my dear students? Just let me know, right? So this is exactly momentum. And momentum is also, by the way, related to kinetic energy, because kinetic energy is nothing but half mv square. I can write this as half mv whole square divided by m. I multiply by m, divide by m. So this mv is becoming momentum. So this will be half p square by m. So this is how kinetic energy is related to its momentum, right? Kinetic energy is also related to the momentum. Now, imagine this Pandu was running like this here. Then what happens is he sees the school principal. He sees the school principal. So his initial momentum was here. He sees the school principal. So he immediately takes a turn and goes to the other direction. He goes somewhere else. So definitely this will be now his final momentum. So I can say Pandu's momentum has changed. Pandu's momentum has basically changed. So whenever there is a change in the momentum, such a thing is called as an impulse. So I would say Pandu has experienced what? Pandu has experienced what? Impulse. So impulse is nothing but the change in the momentum. The symbol for impulse is basically J. J is nothing but the change of the momentum. That means it is final momentum minus your initial momentum. And this is a vector. So bear that in mind. Bear that in mind. Impulse is the change of momentum, final minus initial. Change of laddus, final laddu minus initial laddu. Change of monkey, final monkey minus initial monkey. Change of momentum, final momentum minus initial momentum. Okay, keep this in mind. Obviously, the unit of impulse will be the same as momentum itself. So whatever I put over here should be valid here also, because it is bananas minus bananas, right? Monkey minus monkey. Same kind of units will be there. Kg meter per second, kg meter per second. So this will be also kg meter per second. That is what it would be. Okay, it is also a vector quantity. It is a vector quantity. In which direction? In the direction of the change. In the direction of basically the change. Keep this in mind. Just to give you certain examples on the change in momentum. Just to give you some examples, all right? Let's have a look at some examples so that you understand what this is. Imagine, I tell you, there is a mass like this. It is going with some velocity like this, and it turns by 90 degrees and goes with 2v velocity. Maybe this was a ball. It was going like this. A batsman hit that ball, so that ball changed the direction and it went like that. So obviously there is a change in the momentum. Obviously there is a change in the momentum. And question is exactly that. What is that impulse acting on it? What is the impulse acting on it? So very easy way to solve this problem, my dear students. Impulse is nothing but final momentum minus initial momentum. That is what it is. This is the final direction. This was the initial direction. So you can see there is vector subtraction involved over here. Technically this is PF plus negative of PI plus negative of PI. So do you see initial momentum was this side? So the negative of initial momentum will be towards the left side. Initial momentum was this way. So the negative of that will be this way, right? So can I say minus PI vector will be like this? This will be your minus PI vector, right? Everybody with me? And the value of that will be mass into velocity. That's what the value will be. What is the final momentum? Final momentum is m into 2v. It is upwards as it is. I have to add these two vectors. So I'll place this vector over here. So this is your basically final momentum, which is nothing but m into 2v. Is that right? Everyone with me? So now do you see, by triangle law of vector addition, this is basically the change. This is basically the change delta p, which is also the impulse. Everyone? So what will the magnitude be? It will be root of, use Pythagoras, mv whole square plus 2mv whole square. You can see mv can be taken outside the root. So it will be 1 plus 2 square, which is basically mv root 5. So that is the impulse acting on it. Everyone understood how we calculated? I'll just repeat. A ball was going towards the right. It suddenly turned. Question was to find impulse. So I went by pure definition. It is final minus initial. Vector subtraction. Vector subtraction is actually vector addition, but with a negative vector. Of whom? Pi. So Pi was this way. So I first of all flipped it. Final momentum was anyways here. So I joined the two vectors so that I can form a triangle. So this side I know, this side I know. I know this is basically 90 degree. So using Pythagoras, I found the answer. Cool? Chalo. I'll show you one more question. Okay. Imagine there was a ball of mass m. It was moving with speed u. It hit a wall and it came back with the same speed. It basically bounced from that wall. So it bounced back with the same speed. The question is, what is the impulse? Hello Satish, Tave. Good evening, my dear students. Very good. Keep answering. What do you think is the answer for this particular question? What will you do? Again, use the definition. Our impulse is final minus initial momentum. Now, all the things are in one dimension. So instead of using triangle law and all of that, I think I can just do with plus and minus sign. It will be enough. So final momentum, if you notice, is left side. So I can put it as minus mu I cap. That is the final momentum. If you talk about the initial momentum, is it not mu but in the positive x direction? So it will be mu plus I cap, right? So I'm just taking right side as positive x, right? And this is positive y. So left side will be negative x. So what will this be? It will be minus 2 mu I cap. So the magnitude of that impulse technically is just 2 mu. So a lot of people think the answer is 0. Mu minus mu is 0. No, directions are opposite. So it is actually mu minus of minus mu. So 2 times it is going to come up. So it will be twice of that. 2 mu will be the magnitude. Direction will be in the negative direction. That's how you solve this. Good evening, Jaspreet. Okay. So now that you have a fair idea of what momentum and what impulse is, I think now it's a good time that we talk about the forces as well. So what is the relation between the force and impulse? That comes from Newton's second law. According to the second Newton's law of motion, according to that, the net force acting on a particle, is nothing but dp by dt, isn't it? This is nothing but instantaneous value. So if I talk about the average value, this is how it will be. The average force instead of putting dp by dt, rate of change of momentum was the force. That was Newton's second law. This is instantaneous. Whenever derivative comes, it is instantaneous. Slope means instantaneous. But when I talk about average, I don't take dp and dt. I will take delta. What will I take? I will take delta. Is that right? Everyone? Yes. So this will be a big change in that momentum upon a decent enough time interval. So delta p by delta t. So this will give me basically the average value of the force. Average value of the force, everyone. So now think about it. What is delta p technically? Isn't it impulse? So it is nothing but impulse divided by the time is going to give me average force. Is going to give me average force. That is a very, very important thing that you can see over here. Average force is impulse by the time. How can we find average force using this formula? Let's go back one step. Or over here. Imagine the time of collision. Imagine it bounced back and the time of collision, if it is, let's say 0.1 second, then the wall will exert some force. So what is the force by the wall on the ball? Such kind of question also could have been asked. It collides with it for 0.1 seconds. Hardly, if you slow it down and see, 0.1 seconds it touched it and came back. So the wall was applying a force on the ball. How much force was there? So that force by the wall, I can use that average force formula. It is the impulse divided by the time. The impulse I just figured out, it was 2 mu and the time was 0.1. So take it on the other side. So it will be 20 mu. 20 mu is the force by the wall. 20 mu. Is that right? Everyone with me? Clear? This is how you can find the force acting on any particular object. Let me give you one more example before we go ahead. See, if I tell you, okay, an average force of 30 Newton acts for 0.2 seconds, then the impulse of that force is how much? Impulse of that force is how much? Well, think about it. Is average force related to impulse and time? Definitely. In fact, impulse by the time is your average force. So hence the impulse will be average force into the time interval. Average force is 30 Newton. Time interval is 0.2 seconds. 30 into 2 is 60, but shift one decimal. So it will be basically 6. It is basically 6. Very good. So no, answer is not in Newton, guys. Answer you can give it as kg meter per second, or if you want, this is Newton and this is second, so you can give the answer as Newton second. So it is not Newton, it is Newton second or kg meter per second. Both the units are fine. Both the units are perfectly fine. Is that okay, everyone? Okay. This question which I'm going to ask next, many people make a mistake. So hopefully you will guys will give the correct answer to this question. So there is this ball of mass m and an identical ball here, again mass m. Both of them are basically dropped from this height. So what happens is they hit a surface, but the surfaces are different. Here the surface is very muddy, watery, okay. Here it is little bit, hard ground. So what happens is when this ball hits this surface, it will have certain velocity. And it enters into this slushy land. Because it is very soft mud, it will stop after a long time, maybe over here. So, it will take some long time to stop, maybe somewhere over here. It finally stops. But on the hard ground, what will happen? This mass, once it hits the ground with certain velocity, it takes hardly any time to stop, and it will probably stop right over here. Okay. This is, let's say, situation number 2. Let's say this is situation number 1. This is situation number 1. Okay, this is situation number 1. Question is number 1. The ground would have applied an impulse because there was some momentum and it stopped. So there was a change in momentum, no? 100% there was a change in momentum, right? So if I compare the impulses, basically on one side I put J1 and the other side I put J2. Also the force by the ground, right? You have to predict who is more, who is less. That's all. So this is J1 versus J2, F1 versus F2. J is the impulse, F is the force. J is the impulse, F is the force. They come down, have some momentum, they lose the momentum. So there is a change in the momentum. So whose impulse is more, whose force is more? This is all by the ground. By the ground surface. By the ground on the ball. That's the question. So what will you put? More than, equal to, less than? That's all the question is. That's all the question is. What do you suggest? Sarat saying J1 is more. Joseph Ari saying F2 is more. Okay. Definitely Satvika. I will definitely make a video. Thank you for reminding me of that. J1 is more than F2 and F2 is more. Okay. J2 is more. Pakka lock kiya jaye. J1 more than J2, J2 more than J1, or J1 equal to J2. What should I do? Pakka J2 is more. One of them only said J1 is more. All right. Shall I surprise you? Shall I surprise you, my dear students? What if I tell you J1 and J2 both are actually equal? What if I tell you J1 and J2 both are actually equal? Yep. You know why? Whose velocity will be more, guys? The first one or the second one? When they hit the ground, whose speed will be more? Just before hitting the ground. Same mass, same height, dropped. Same gravity. So obviously their velocities will be same, right? If this is V, naturally even this will be V. So if you talk about the impulse, magnitude, it will be nothing but final momentum minus initial momentum. What is final momentum? They stop, right? So they stop, right? 0. Initial momentum, what is it? It is basically mv, right? Both of them have mv. So magnitude of that will be just mv only. So isn't the impulse the same? Isn't the impulse the same? So hence the answer will be equal to. Understood? So even if one takes long time to stop, another takes, that's it, it stops. Impulse is the same. I know you guys are not convinced. You are thinking, sir, I thought impulse means, sir, large force, small time. That is what the problem is. Many schools, many people tell you wrong things. Impulse is not force. Force is not impulse. Impulse is not large force in a small time. Who said all these things? If they have said, they have told you wrong concepts. Impulse is not large force in small time. Impulse is the effect of force and time. Notice, impulse is the effect of force into time. Force and time's effect is basically impulse. It is the change of momentum. Change of momentum was the same. What about the force? Well, force is impulse by the time. This guy is same for both. Obviously, this is different. So the one which takes more time will have less force. This took more time to stop. So this will have less force. So F1 will be less than F2. F1 will be less than F2. Very interesting problem, guys. Here the force will be obviously more because it has to stop it in a very small time. Here the force is very less. Say it will stop. Very slowly it will stop. Coolly it will stop. Okay, so understand the difference. Also, you might have heard this thing like, sir, but somebody told me large force, small time, impulse. See, I'll tell you what it is. When there is a large force, okay, which can change the momentum, in small time, then it is said to be impulsive force. Look at the adjective. It is not a noun. It is an adjective. Impulsive force. That force is said to be impulsive. Example of this is a bat hitting a ball. Bat hitting a ball. Or a vehicle colliding with a barrier. All these things. Or carom, coin, striking other coin. In all these examples, what happens? There is a sudden force and it changes the momentum significantly in a small time. So that force of collision, explosion, whatever, interaction is said to be impulsive in nature. Force is said to be impulsive, understood? But then there are these slow forces. Imagine a decent or small force that takes long or decent time to change the momentum, then that force is said to be obviously non-impulsive force. Non-impulsive is an adjective here again. Non-impulsive force. The force's quality is non-impulsive in nature. Keep that in mind. Example of that. Imagine a block goes and hits a spring. The spring aram se, slowly it will compress. Or gravity pulling some mass. Slowly the mass will accelerate. It takes some time for the mass to gain some momentum. It's not like a bat hitting the ball within 0.1 second, tuck, it has got some momentum. No. Okay, so keep that in mind. So example will be like the spring force or the force of gravity. All these are basically examples of non-impulsive forces. Is the difference clear? Everyone with me? So many students do not know all these things. That's why it is my job to come over here and to tell you and to make sure that you know concepts correctly, not by shortcuts, not wrong concepts for sure, and no misunderstandings. Else, I would not be doing justice, right? And that is why you come on this channel. And I hope you have smashed the like button till now. If you have not done that, if you have not shared the video, if you have not commented, if you are watching recorded, make sure you do that right away. Okay. Now going back over here, F was dp by dt. So let's play around with this formula only. F is dp by dt, right? So shifting the terms, dp will be nothing but f dt. dp will be nothing but f dt. Integrating both sides, integrating dp, integrating force with respect to time. Integration of dp means small change in momentum plus small change in momentum plus small change in momentum plus small change in momentum. Integration means adding. dp means small change. I add all of them. What do I get? I add all of them. I'll get the total change in momentum. This will be integration of the force with time from the time it started till the end. From the start till the end. T1 and T2 are the limits of the integration. This will be a definite integration. Keep this in mind. This will be a definite integration. So from this, you can also tell one more thing. That is, if you give me a graph of the force acting on the body versus the time. Force acting on the body versus the time. And let's say that graph happens to be something like this. Okay. Look at this. The force is variable. So when a bat hits the ball, the force is not constant. It will change, right? When it just touches, the force is less. Then the force will become more. And when the ball leaves contact with the bat, then the force keeps on reducing. So it will be some irregular curve. Any two vehicles collide. Dishum. Do you think the force will be suck 100 Newton and then suck 0 Newton? No, right? It will take some time. 0 Newton, 10 Newton, 20 Newton, 25 Newton, 30 Newton, 100 Newton. So it will be a variable graph. It will be a variable graph. So my dear students, this is a force versus time graph of that force which is trying to change the momentum. So if you integrate, that means you want to find the area. Area under the curve is integration with limits. integration with limits, definite integration is nothing but area under the curve. So if you happen to just choose this area, if you happen to choose this particular area, right? So this is basically your T1. Let's say this is basically your T2. From this point to this point, there was force, there was collision. So that will be nothing but the change in the momentum or impulse. So impulse is also the area under the force versus time graph. Force versus the time graph. Obviously, this is just an extension of this same formula, nothing more. Correct? So this is also very, very crucial. Everyone with me? Shall we go ahead and solve some questions on this? Thank you, Satish. All right. So let's go. There we go. Imagine it is given the force is basically 2t square Newton, okay, and it acts from 0 to, let's say, 3 seconds. Question is find the impulse and also the average force. This is the question. Find the impulse and the average force. Remember, to find average force you need impulse, because average force was impulse by time. So I think the first job will be to find the impulse. Okay, now think and tell me, here the force is constant or variable? Look at this function and think and tell me, is the force a constant or is it a variable? Force has time, that is squared. With time force changes, so it is definitely not a constant. And whenever force is not constant, the only option that I have is use integration from lower limit to upper limit to find the impulse, right? So let's do that. So impulse will be integration of the force with respect to time from T1 to T2. Here that force is 2t square, 2 is a constant, bring it outside. So t square dt is integration from 0 to 3 seconds. You can see the lower limit and upper limit. Time interval from this time to this time, lower limit to upper limit. Correct? Definitely. You can see that. So this will be nothing but 0. This is nothing but 3. So this will be 2. T squares integration. Come on, remember x raised to n formula. X raised to n plus 1 upon n plus 1. So t raised to 2 plus 1 upon 2 plus 1. And put a box, put the lower limit, put the upper limit. So therefore, the impulse will be, check this out, this will be 2. Okay, first put 3 over here. So this will be 3 cube by 3. 3 cube by 3 minus, then put 0. 0 cube by 3. So this will become 2. 3 cube by 3 is 3 square minus 0, of course. 3 square is basically 9. 9 twos are basically 18. So 18 Newton second. That is the impulse. That is the impulse. So we found the first answer. 18 Newton second. How many of you got it? Very good. Leisure Bunny, Subhashini, very good. Priyanka, awesome. Keep on answering. Keep on, staying up to date with the class. Very good, guys. Proud of all of you. Now the next question is average force. I think we know the formula. Average force is impulse by the time interval. What is the impulse? It is just right over here, 18. What is the time? 0 to 3, 3 seconds. So 18 by 3. So 18 by 3, come on, 6 Newton. So 6 Newton is the average force. So the force kept on changing, but the average force was basically 6 Newton. That's how you solve this question, right? So these kind of questions are very, very popular, guys, where area will be given or function will be given, and then you have to find the impulse or the average force and such things, okay? So one more question I will give you, graphical. Try to solve this as well, and then we'll go to law of conservation of momentum. So imagine there is a graph given like this. Okay, this is basically force, this is basically time, like this, and the graph goes in this manner. It increases, goes down, and goes here. Let's say this is basically, -1. Let's say this is basically whatever, 4. let's say this is basically 4, let's say basically this is 6. Okay, these are the some values which I have just taken randomly. The question is find the average force. Find the average force. What do you need to find average force? Remember, you need impulse. To find impulse using graph, you need area. So what will be our first step? Finding the areas under the graph. Okay, chalo, everybody start calculating what is the area under the curve. So this is a triangle. Area under the triangle will be half base into height. Height is also 4. So basically it is nothing but 8 over here. 16 by 2 is basically 8. Okay, what about this one? This is below. So the area must be negative. Area must be negative. Yes or no? Area is negative because it is below. Half into base. Base is 6 minus 4. So that is 2 into height, which is basically 1. So basically, is it not minus 1, guys? Is it not minus 1, guys? Okay. Thank you, Tabish. Thank you so much. So what is the total area? Because that will, what will give me the impulse? It is the area under the curve, the total area under the curve. It is nothing but 8 minus 1, that means it is 7. Okay, impulse is 7, Newton second. So what will be the average force? What will be the average force? Impulse upon the time. Impulse is 7. What is the time from 0 to 6? 0 to 6, 0 to 6, 6 seconds. So the answer is basically 7 by 6 newtons. 7 by 6 newtons. That is the answer. Simple, easy peasy, lemon squeezy. Everyone with me on this? Clearo? We have done all varieties of questions, my dear students. After this, you cannot have any difficulty, at least in impulse, momentum, right? Average forces, graph-based questions, anything. Okay. Now, it's time to move to types of collision, explosion, all those things. So for that, we need to study something called as conservation of momentum. Conservation of momentum. So lot of things are conserved in this world, right? So many things. Like law of conservation of marks, I heard. If one student gets more marks, one student gets less marks. Happens. One person gets more money, other person gets less money. So one person gets more momentum, the other person gets less momentum. It will not happen that everybody in the world becomes rich. Not possible only. Everybody becomes poor, also not possible. So all the masses get large momentum, not possible. If something gains, something loses. If something loses, something gains. So that is the law of conservation of momentum. Law of conservation. Law of conservation of momentum. In this law, or when you apply this law, there are always two things that you always draw. One is the situation before and one is the situation afterwards. So it could be many things that could be happening. Maybe there are multiple masses over here. Let's say M1, M2, M3, M4 like that. So this is basically your system. What is this? This is basically your system. And on this system, these particles could be moving here, 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 wherever they want. They have their own momentum, so they have some total momentum of the system. This is before. After some time, that same system may be looking little bit different. Maybe they hit each other, they collide with each other, they explode, whatever. Things might happen, they might interact. Maybe one of these masses goes here, maybe this mass goes here, maybe this goes, let's say, here, something like that, or maybe here, okay, something like that. So these masses have changed their directions. The system has changed its properties. But if external force is 0, from outside, external forces are not there, basically. The net external force, if it is 0, then this is very, very important. If the net external force is 0, then the total momentum, of the system initially will be, or before, will be equal to the total momentum of the system, finally. or afterwards. This is basically the law of conservation. From outside elements, they are not there, or even if they are there, they are getting cancelled. Then you will see the total momentum before and the total momentum afterwards will always be conserved. I hope this is clear. Okay. Right? Yeah, Satish, that's what. No. If one teacher is giving all the students high marks, then there will be somebody else giving low marks. I don't know who it is. Law of conservation of marks by a teacher. Okay, great. Chalo. So this is law of conservation of momentum. I will show you certain applications related to this. I'll show you some applications related to this. Okay, have a look. Have a look. Imagine there is something over here and it basically explodes. It basically explodes. Let's say this is mass m. Okay, it explodes. So after explosion, all right, it divides into two parts. One part is, let's say, m by 3 and the other part is, let's say, 2m by 3. So basically they have been split in the ratio of 1:2. m by 3, 2m by 3, 1:2 ratio. So there was a mass, it exploded into two parts. This is a system before, this is a system afterwards. Obviously, there is a force of explosion. There is a force of explosion because of which they went off. Is this force of explosion external or internal? Is this force of explosion, is it internal or external? Come on, think and answer, my dear students. If you take the entire thing as a system, it's acting within the system. 1 on 2, 2 and 1. Is it not internal force? Is it not internal force, my dear students? Think about it. Pakka? Yes, very good. So this force is internal. This force is internal. So can I say right now on the system, on the system, I can say that the net external force is 0. So whenever external force is 0, then initial momentum is final momentum. What is the initial momentum, my dear students? The mass was at rest before it exploded. This was at rest. So the initial momentum will be 0 because it was at rest. It was at rest. What is the final momentum? Well, assume this guy has a velocity v1. This guy has a velocity v2. This guy has a velocity v2. This guy's momentum will be 2m by 3 into v2. It is going towards the right side. I will take it positive. This guy's momentum will be m by 3 into v1 but a minus sign. Why? Momentum is a vector quantity. Momentum is a vector quantity. So be careful with the signs. It's going right, generally right side, positive x-axis. So I'll take it positive. This is going opposite to positive x, so negative. If you want, shift it on the other side. So it will become m by 3 into v1 will be 2m v2 by 3. m by 3 cancels. So what I get is v1 is equal to 2 times of v2. So this guy's speed is double this guy's speed. Makes sense. The heavier mass will be slower. The lighter mass will be faster. Heavy mass, slow. Light mass, fast. Okay, momentum will be balanced. Make sense? Everyone with me? Clear? Okay, so this is a very good problem on conservation of momentum. Let me give you another question on explosion where momentum is conserved. Where momentum is conserved. Okay, have a look at this. Have a look at this. Okay, imagine there is a big mass and it explodes. This mass is basically at rest and it explodes but this time into 3 particles going in 3 different directions. One mass m goes like this with some speed. Another mass, same m, goes here with a speed of v. This mass remaining is 2m. So total mass was, let's say, 4m. Total mass was 4m. One particle goes here, one particle goes here. This mass will have some speed. The question is, what is the speed of that mass? What is the speed of that third particle? Both of these particles are going in perpendicular directions. Okay, perpendicular directions. Okay, let's try to solve it. What do we do? For this system, again, isn't the force of explosion an internal force? Isn't the force of explosion an internal force? Again, there is nothing from outside which is making it explode. So again, I can use the same concept that the net external force is 0. So whenever this happens, the initial and the final momentum should be equal. So I can say that the momentums will be definitely equal. What is the initial momentum? Well, it is at rest. So if it is at rest, obviously it is 0. Here comes the problem. This momentum is somewhere, this momentum is somewhere, this is somewhere. So one way is use Pythagoras geometry and all that. Other way is use IJK method. Other method is use IJK. If you use IJK, I think it will be easy. So what is the momentum of this guy? It is minus mv I cap. Minus mv I cap left side. What is the momentum of this guy? Minus mv j cap. What is the momentum of this guy? I'll just say it is 2m v bar. It is 2m. I don't know what it is. I'll just say 2m v bar. Okay. One thing is there. M will get cancelled. M will get cancelled. M will get cancelled because here 0 is there. So m gets cancelled. So what I can do? Bring this guy here. Bring this guy here. So it will become, therefore, v I cap plus v j cap is equal to 2 v bar. So therefore, v bar will be the velocity of the third particle. I can call it v3 also if you want. Don't get confused. So v3 will be v by 2. v is common. 2 brings it down. Okay. I cap plus j cap. So that is the velocity. You can see both I cap and j cap are positive. That means this mass will be moving somewhere here. Somewhere here. Something in I, something in j. Gonna make sense also logically. If one goes down, one goes here. So other has to go there to compensate for the momentum. Correct? Now, if you want to find the magnitude of this, it's very simple. So V3's magnitude, this was the vector, the magnitude will be, just take V by 2 is common, root of, whenever you want to take the magnitude, coefficient square plus coefficient square plus coefficient square of I, j, k, square, 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 put it under the root. So 1 square plus 1 square, which is nothing but, how much guys? It is root 2. Right? If you want, you can also write this as v by root 2. So that is the velocity, v by root 2. Okay? Everyone with me? Yes. Great, great. Good evening, everyone. Good evening. Join in and concentrate on the topic. We'll do other topics also when time comes. Okay? So whatever you want to ask, make sure that you're asking with related to the topic. Okay? Not something else. All right. So this is how you conserve the momentum in different problems. Okay, you just need to check external force is 0. Only then you can say initial momentum is equal to final momentum. Otherwise, it is definitely not right to say so. Okay, keep that in mind. Now, these questions, if you noticed, everything was exploding, right? Exploding, and we conserved the momentum. But we did not talk about collision, and that is exactly what I want to talk. Yes, account, you can watch these classes. We talked about explosion, but there are also questions where things collide, stick together, and so many other cases. Now, when collision happens, there are actually 3 types of collision. So what are those 3 types? I will tell you. So let's talk about collisions now. Let's talk about collisions. Okay. So you have some mass over here, some mass over here. Maybe it comes like this. Maybe this comes like this. Maybe this is M1. Maybe this is M2. Maybe this is U1. Maybe this is U2. Correct. So this is before. Afterwards, maybe this mass might decide to go like this with velocity v1, and maybe this mass maybe goes like this with velocity v2. Now, when they collide and they go like this, or they come like this and go like that, or they are going like this, they collide and go like that, or they are coming from here and they go like this, all these are collisions. In all these collisions, the force of collision is internal. The force of collision, the force of collision is basically internal force. So don't worry guys, if I take this whole thing as my system before and afterwards, no matter what the directions are, I can clearly see from outside the net external force is basically 0. So momentum is conserved. Hence I can say M1 U1 bar. Bar is important, not just U1, because it's not a 1D question. You are no longer in 9th standard. You are in 12th or maybe dropper student or maybe 11th standard students. Yes, Pandu Champa collision. Pandu is running, meets Champa, dham, they collide and they go somewhere else. Hai na? Humpty Bumpty had a fall. Okay, so M1 U1 is the initial momentum, M2 U2 is the also the initial momentum but of the other particle. So this is the total initial momentum. So this is basically the total initial momentum. What will this be equal to? This will be equal to the total final momentum. So M1 V1 bar plus M2 V2 bar. So this is basically your total final momentum. Is that right? So this is your law of conservation of momentum. Obviously, these are sign sensitive. This could be positive, negative, maybe it is I cap, J cap. So many things are possible, right? So guys, these are basically sign sensitive equations. Be very, very careful. But, there is a but now. Even if the momentum is conserved, now there is a but. What is that but? K1, initial kinetic energy of the system of this guy, plus K2, initial, may be equal, may not be equal to the final kinetic energy, K1 plus K2, finally. May be or may not be. It depends. It could be equal to, it could be less than, it could be more than. There is no clear cut answer, depends from problem to problem, depends on the nature of the collision. So in every collision, no matter what, momentum is always conserved, but kinetic energy may be equal, may not be equal. It could be anything. So hence I would just say it depends. It depends. So it's a big question mark. It's a big question mark. It depends on the, what does this depend on? The nature of the collision, the nature of the type of, things meeting each other. How the nature matters? Think like this. If you take cheese pizza, what do you take? Cheese pizza, right? That pizza you took. You got very angry. You are playing with your friend or brother, sister. Got very angry. Take that pizza and throw it on your brother's or sister's face or your friend's face. You got very angry one day. Something happened and you threw it. Thup, it fell on his face. It got stuck. Energy got lost. Sound came. It got deformed. It made bond. Something happened. Energy is lost. Bye-bye. Tata. So kinetic energy is not conserved. Yes or no? Kinetic energy is not conserved. Everyone? But imagine you are playing carom or you are taking a playing snooker or you are on the pool table. That ball goes, rolls, hits the other ball, transfers all the momentum and transfers all the kinetic energy. Or you take marbles. One marble comes, hits the other marble, that other marble starts moving. You would have also seen Newton's pendulum, which is basically many pendulums beside each other. You take one pendulum and leave it, that pendulum comes down, hits the other, that hits the other, that hits the other, and the last pendulum comes out. So the momentum tuck, 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 tuck goes, that energy also tuck, 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 it goes and goes to the other or the last particle. So in these collisions, energy is conserved. Whatever is there before is there afterwards. So, my dear students, kinetic energy may be lost, may be gained, could be anything. Imagine an oil tanker, petrol tanker collides with another petrol tanker. You might have seen some videos. Have you seen such videos? Accident videos, fun videos, disaster in seconds. Hai na? So some truck is going, carrying fuel, another truck going, or a small car, है ना? It collides. What will happen once the collision happens? That oil, that petrol, the diesel will burn. Boom! Explosion. That car goes off flying. The truck also goes flying. Where did they get the energy from? From the internal energy of the system, from the explosion. Because of that petrol, it exploded. That chemical energy got converted into heat. That heat got converted into kinetic. So many things are there. So point is that kinetic energy may be conserved, may not be conserved. May be conserved, may not be conserved. So whenever you see there is an explosion, which is the previous cases, whatever we saw over here, in case of explosion, you will see that the initial kinetic energy is less than the final kinetic energy. Initial kinetic energy is less than the final kinetic energy. So basically the kinetic energy increases, this increases, and that increase comes from where? From internal sources. Internal sources, not external. Generally the internal sources. Like gunpowder exploded, petrol caught fire, or something which, caused that explosion. Some energy was stored inside, some spring-like system, it exploded, it threw those particles. So these are, typical the scenarios of explosions, my dear students. Yeah, understood, guys? I'll fill that petrol into my bike. Yes, Satish, but I hope you do not explode nor the bike explodes. So collision is fine, explosion is bad. Great. But in collisions, the kinetic energy may become less, may be equal, and according to that, you have three different scenarios. First is elastic collision. Next one is inelastic collision. The last one is the worst of the worst kind. It is basically perfectly inelastic collision. So what are these three types of collision? Okay, perfectly inelastic, and just elastic. Please remember, there is nothing called as perfectly elastic collision. Elastic means perfectly only. There is no point using perfectly elastic. So people get confused, like perfectly elastic, inelastic, perfectly inelastic. Sir, 4 types of collision, no sir? Hey, nothing like that. Perfectly elastic, remove it from your head. Okay, cool. Chalo, awesome. So what are these types? So let's make a difference table. Obviously it will be very useful for all of you. Okay, let me start with examples. Proton collides with another proton, or basically a good rubber ball with some elastic wall. These are good examples. You take a rubber ball, some nice rubbery wall is there, it absorbs and gives it back. So the ball does not lose energy. Whatever speed it came and struck the wall, same speed it will bounce back. If it loses energy, then it is not elastic. So here, the kinetic energy initially, the total kinetic energy initially will be the total kinetic energy final. So there is basically no loss of energy. Remember this, no loss of energy. Inelastic collision, most of the collisions are inelastic. Like imagine an accident which happens on the road. Most of them are inelastic. A biker is going, dub, it hit a car, and this car went this way, bike went that way. The car will get a dent, no? The bike, one part, mirror will break, no? So where did that energy come to bend it, to break that mirror? Somebody spent, no? So that kinetic energy has been spent to cause a dent, deformation, to break bonds, to break those parts. Sound came, definitely. Sparks came, light came. So some energy is lost. So these kind of collisions are inelastic. Or even most likely, most of the marbles when they collide, some sound will come. most of the collisions around us, or rather I would say a ball hitting a bat, hits a bat. You hear a sound, tak karke. Haven't you heard that sound? Even when you watch cricket, whether the batsman has touched the ball, there is a sound graph which comes, whether the catch is valid or not. To check that, you see whether the bat has hit the ball. So if the bat has hit the ball, there is a sound. So there is sound energy being lost. So most of the collisions around us are basically inelastic in nature. So in this case, you will see that the total initial kinetic energy is generally more than the total final kinetic energy. So there is a loss of energy. Loss of energy. Is that right? Everyone with me? Yep. Carom also. Yes, in carom also. Perfectly inelastic means they will stick to each other. Stick to each other. Or, a bullet getting embedded in a block. So something is moving, it gets stuck to it and they both move together. That is perfectly inelastic collision, guys. What is that? That is a perfectly inelastic collision. So in this case also, the final kinetic energy is more than, initial kinetic energy is more than the final kinetic energy, but there is maximum loss of energy. Maximum loss of energy. You can't lose more than this. That is why I said this is the worst kind of explosion. This is the best, collision. This is the best kind of collision. This is the worst collision. This is the best collision. This is okay. You lose some energy. Is that okay? There is one more point, but for that, we need to talk about something called as the coefficient of restitution. Coefficient of restitution. Coefficient of restitution. This coefficient of restitution is a very good number. It's a ratio. It tells you what the collision is. So many of you are asking, sir, how do I know which collision it is? Don't worry, in the exam, in the question paper, it will be given. One number. Just looking at that number, you can tell me, oh, it is elastic. Oh, it is perfectly inelastic. Oh, it is inelastic. So that is that number. Hello, Gautam. Welcome aboard. So that number is nothing but called as E. It is the relative speed of separation. Relative speed of separation after the collision. After the collision, the whole thing upon the relative speed of approach after the collision. Who discovered this? Newton. He was aram se peacefully chilling, playing with marbles. Tuck, tuck, tuck. He was playing with marbles and then looking at the marble speeds, calculating that. Very, very, he was not fun loving. He was very boring. He was like, okay, let me calculate this speed. Let me calculate this speed. Let me take this ratio. And he found that one ratio is coming out to be constant for these marbles. Then he brought another set of marbles made of steel. He saw the ratio is same but a different value. So then he understood, oh, for a pair of colliding bodies, this ratio of relative speeds before and afterwards is constant. He gave that number coefficient of restitution. He gave that number, the value coefficient of restitution. Example, imagine there is a ball like this, this is before, this is afterwards. Let's say this is coming with a speed of 2. Let's say this is coming with a speed of 4. Here it is now going with a speed of 1. This is going with a speed of 2. Okay. And question is find the coefficient of restitution. Question is find the coefficient of restitution. Remember, it is always afterwards upon before. After upon before. Everything is relative. Everything is relative. Afterwards, this one. Relative speed. What is the relative speed? They are separating, they are going away from each other. This is going 2 this way, this is going 1 this way. Shouldn't it be 2 plus 1? Shouldn't it be 2 plus 1? It is speed, it is never negative. I've seen many teachers and many institutions and many books making you by heart some formula. Tell me if I'm wrong. Minus V2 minus V1 upon U2 minus U1. And then in the exam, like, sir, was it V2 minus V1 or V1 minus V2? Was the minus sign up or the top? Was it U1 minus U2? Which side was positive, sir? Got confused. Lost marks, wasted time. Don't waste your time by hearting that stupid formula, not needed. Shreyas sir is telling you. Captain Shreyas sir is telling you, no need of that formula. Just remember this much. It's more than sufficient. It's more than sufficient. Just, if you know the concept of relative speed, put that speed on the top and below. That's all. That's all. Acha, I wrote. Oh, sorry. This was before. My bad. This is before. My bad. Sorry. Yeah. Relative speed of approach before the collision. My bad. Yes. So, this is after 2 and 1. And what is before? 2 and 4 are coming like this. Again, they will add. So, 2 plus 4. 2 plus 1 is 3. 2 plus 4 is 6. So, basically it is 0.5. So, coefficient of restitution is 0.5. That's all. That's how you calculate relative speeds, divide them and find coefficient of restitution. Now, this coefficient of restitution tells me whether it is elastic or inelastic or perfectly inelastic. If at all it so happens it is elastic collision, then this value of E comes out to be 1. That means with whatever speed it approaches, exactly same speed it separates. Whatever speed it approaches, exactly same speed it separates. Number 1. If it is inelastic collision, then the value of E is not equal to 1, it is less than 1, but it is not 0 also. Only in perfectly inelastic collision, the value of E is 0. That makes sense. If E is 0, that means the numerator is 0. That means the relative speed after separation is 0. They are not separating only, they are going together. They are going together. What is the relative speed? If they are going together, it is 0, right? Numerator is 0. Hence, E is 0 because they stick to each other. Keep this in mind. So, that's why E is 0 for perfectly inelastic collision. Is that understood? Good evening, Buddha Surya. I hope this is very, 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 very clear. So, now we can start solving some questions. Ready for questions? Ready for questions, my dear warriors? Okay. Chalo, let's do some questions. Here is the question. So, imagine so there is an elephant, it is wearing roller skates like this and it is traveling like that. Okay, it is traveling like that. Let's say the mass of the elephant is 900 kg. Okay, and it is moving with a speed of, I don't know, 10 meters per second. Something like that. Okay, everybody with me? Then what happens? From behind, there is one hunter, some evil person, some poacher. He shoots a big cannon ball towards the elephant. Towards that elephant. So there is a big cannonball towards that elephant. That mass of the cannonball is, let's say, maybe 10 kg and maybe it is moving at 100 meters per second. Crazy, right? 100 meters per second. This is before. Now what happens afterwards? That cannon strikes the elephant obviously gets killed, poor elephant, sacrificed his life for the sake of this problem. So now it has been killed. So this is some blood over here. Okay. Great. So now this dead elephant, let's assume it's still standing. It will be having some new speed. It will be having some new speed. The question is, what is that speed? The question is, what is that speed? Yes, that elephant is wearing roller skates. Now my point is, first of all, is this collision elastic or inelastic or perfectly inelastic? Answer that. If you answer that, then we will solve this problem very easily. Is this elastic, inelastic or perfectly inelastic? Come on, guys. Is that elastic, inelastic, or perfectly inelastic? It is perfectly inelastic because that cannonball sticks to that elephant and they move together. It sticks to that elephant and they move together. Yes or no? Yes. Hey, who is that elastic fellow? Elastic fellow. What? That cannonball is hitting that elephant is absorbing everything and then throwing that cannonball on that hunter's face, is it? It is absorbing that energy and throwing it back. It is getting stuck in it. When that masses get stuck together, they move together, embedded, then it is perfectly inelastic collision. How can it be elastic? You're saying, boom, they collide and they go like this. What are you saying? No, no. Understood? Oh, clear? Oh, yes. Pierces through that elephant. Yes, Jasper, I know it is probably not a very good scene to see, but yeah, we have to solve the problem. So it is definitely a perfectly inelastic collision. So can we find that? Yes. Momentum is conserved. Momentum is basically conserved, my dear warriors. So what is the initial momentum? This guy's mass 10. This guy's velocity 100. This is of the cannonball. This is of that cannonball. This is of that cannonball. Plus momentum of the elephant. It is 900 into basically 10. This is of that elephant. This is of that elephant which is alive right now. Correct? Finally, what will be the total mass? Finally, what will be the total mass, my dear warriors? Finally, what will be the total mass, my dear warriors? Okay, let's do one thing. Let's keep the values little bit good. Let's make this 100 kg. Let's make this 100 kg. So the values will come out to be little bit better, I feel. So I'm just changing the mass of the cannonball as 100 only. So this will be 100. Okay. And yeah, this let's make it as 10. This let's make it as 10. This is 10 meters per second. So this will be 10. Okay. So now think, if I take this as 100 and this as 900, when they combine together, that mass will become how much? 1000 kg, 1000 kg, and the new velocity will be v. This is of the dead elephant. This is of the dead elephant. Correct? Awesome. So now cancel all the zeros, whatever you need to. 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's it. So this will become 1 plus 9 is equal to v. So v will become basically 10 meters per second. That is the answer. Is that fine? Everyone with me? 900 plus 100 is 1000 and that is v. So this was 10 and this was also 10. That's all. That's how you get it. Everyone understood? Oh, clear? Oh, perfect. Great. Now let's take another example. Let's take another example. Imagine there is a mass which goes with some speed u and there is another mass. Let's say this is 2m and let's say it is at rest. And now I don't know what happens later on, but in fact, I know one thing, the coefficient of restitution is 0.25 or let's take it as 0.25. Question is, what are their final speeds? What are their final speeds after the collision? This is before, this is afterwards. Question is, what are their final speeds? That's all that is asked. So let's try to solve the question. Everyone with me? First of all, tell me, looking at the value of E, is it elastic, inelastic, or perfectly inelastic? Elastic, inelastic, or perfectly inelastic? Come on, guys. Come on, guys. What will be the type of collision be? It will be a inelastic collision. It will be a basically inelastic. And no matter what the collision is, momentum is always conserved. So if I assume afterwards this speed is v1, this speed is v2, initial momentum is just mu plus 0 is equal to mv1 plus 2mv2. M cancels, so therefore u will be equal to v1 plus 2 times of v2. This is equation number 1. v1 plus 2v2, m has been cancelled. I have just conserved the momentum. I have just conserved the momentum. Just conserved the momentum. That's all. Nothing else I have done. But I don't think I can still solve this equation because V1 and V2 are not known. V1 and V2 are not known. I need something else. I need something else. What do I need? I have to use this value E. So to use this value E, let me write down the equation. E will be separation by approach. Separation by approach. In the next step, I will put this as 0.25. 0.25. Separation by approach. Look at this. After collision, they are separating. After collision, they are separating. So what is the relative speed of separation? What is the relative speed of their separation? V2 is faster than V1. It collides like this and they go like that. V2 plus V1 or V2 minus V1? V2 plus V1 or V2 minus V1? Come on, my dear students. What should be the correct answer for this? Shouldn't it be V2 minus V1? Higher speed minus lower speed. This is going at 7, this is going at 2. So 7 minus 2, 5. 5 will be the relative speed. Clearo? Understood? So they collide like this. V2 is fast, V1 is slow. So if this is 7, this is 2. 7 minus 2, 5 will be the relative speed. This is 9, this is 4. 9 minus 4. Like that will be the relative speed. Cool? Okay. Upon approach, what is the approach? This is U, this is at rest. Approaching at how much speed? U only. Okay. So U minus 0 you can say, or just you can put it as U, no problems. So now you can say 0.25 is V2 minus V1 divided by U. Take U on this side. 0.25 is basically 1 by 4. So bring 4 on the other side. So U will be, what is it? 4 times of V2 minus 4 times of V1. This is your second equation. Look at equation 1, look at equation 2. Look at equation 1, look at equation number 2. In these two equations, do you see there are two unknowns, two equations? Two equations, two unknowns. I can definitely solve them. How do we solve them? Take this equation, right? Take this equation, multiply it by 4. Multiply it by 4 because this 4v1 and 4v1 will get cancelled. So this will technically become 4u is equal to 4v1 plus 2 into 4 is basically 8. So 8 times of v2. And below that, just put this equation, u is equal to 4v2 minus 4v1. Now you just add both of them. You just add both of them, guys. 4u plus u is basically 5u. 4u plus u is basically 5u. 4v1 and minus 4v1 will cancel. And here you will get 8v2 plus 4v2, which is nothing but 12 times of v2, which will be nothing but 12v2. So what will be v2, guys? v2 will be 5u by 12. v2 will be 5u by 12. Now use this in any of the equations. Let's say equation number 1. Let's say this equation number 1, you can use it. So u will be equal to v1 plus 2 times of v2. Whatever v2 we got over here, we will substitute. 5 times u divided by 12. 5 times u divided by 12. Take this guy over here. So v1 will be u minus 2 5s are, or basically this will cancel like this. So minus 5u by 6. So this will become 6u minus 5u divided by 6. So it will become u by 6. So that is nothing but your v1. So v2, v1, both values we got. v1, v2, both values we got. So this is how you solve these kind of questions where the value of E is given to you. Value of E is given to you. Clear, everyone? Okay. Now, what if in the same question, this m which was traveling u, this 2m which was basically at rest. Imagine in that same question, I just tell you it is elastic collision. I tell you already it is elastic, and then I ask you to find the speeds. In this question, won't this part be the same? Won't this part, conservation of momentum part, be the same? Like you will assume again this is v1, you will again assume this is v2. So again conserving momentum like before, what will you get? Exactly this equation, u is v1 plus 2v2. you will still get u is equal to v1 plus 2 times of v2. You will still get this equation, yes or no? But the only difference will be over here, this coefficient of restitution. So here you will say 1 is equal to relative speed of separation v2 minus v1 upon relative speed of approach. How much is it? U. Take u on this side, so u will be nothing but v2 minus v1. This will be your second equation. You know what you will do next? You know what you will do next? Just add 1 and 2. Just add 1 and 2, that's all. First equation plus second equation. What will you have? U plus u is basically 2u. v1 minus v1 cancelled out. 2v2 plus v2, that will be 3v2. So therefore, v2 will be 2u by 3. You are getting a different answer as from before. This was 5u by 12 because e was different. Here e is 1. So v2 is 2u by 3. I'm getting a completely different value. Again, we can make use of this equation here. U is nothing but v1 plus 2 times of v2. v2 is basically 2u by 3. So let's do the math. So therefore, v1 will be u, take this on the other side, minus 4u by 3. So this will be nothing but minus u by 3. This is what I get the value of v1 as, minus u by 3. The moment I get minus value, what does it mean? What does it mean? Come on, put it up in the chat box. What does it mean? If I get these values, it just means whatever direction I have assumed is wrong. Actually, after the collision, this is what will happen. These two masses, this is m, this is 2m. This m mass will go with the actual speed of u by 3, and this 2m mass will go with a speed of 2u by 3. That's all. That's all that is going to happen. Opposite directions. That's all. Nothing else. Don't get scared. So I got minus answer. Oh my god, I've done something wrong. Oh my god, where did I do? Nothing. Only the direction is opposite. That's all that minus sign is saying. Nothing else. Don't get scared. Now there are some very interesting things which happen with elastic collisions. And those 3 different things I'm going to tell you. Okay, very, very interesting thing. Only for elastic collisions. Only for elastic collisions. The first one that happens is something like this. Imagine this is mass m, this is also mass m, this is going with speed u1, this is going with speed u2. If both the masses are identical, then after the collision, this will be u2 and this will be u1. What do I mean by that? Let me tell you an example. Imagine there is a 3 kg mass. This is also another 3 kg mass. Can you tell the difference between these two 3 kg masses? Nothing. They are just 2 identical masses, right? Now, imagine this is going with a speed of 7 meters per second. Imagine this is going with a speed of 2 meters per second. After the collision, assuming it is elastic collision, assuming E is equal to 1, after the collision, you know what will happen? This 3 kg will have this guy's speed, this 3 kg will have this guy's speed. Obviously, direction is also maintained. This 2 was here, so now this will move with 2 meters per second. This will come over here. Basically, speeds, velocities, they get exchanged. Velocities get exchanged. That's all. Awesome. This is only true for equal masses. Don't do it if it is 3 and 4, 3 and 5. Don't do that, even if E is 1. Okay? Be careful. Only when masses are equal and E is 1. Only then this will happen. Otherwise, it won't happen. That's why I'm explicitly mentioned elastic. I have told M. That's the reason. Okay? These are all silly mistakes. And students come and ask me, sir, I did this. In this problem, I got wrong answer. Hey, bhai, did you see the question? It was not even elastic. You see, one was 3 kg, one was 4 kg. So, be aware. Second one. If there is a very heavy mass and there is a very small mass, this mass is at rest. This mass comes to this mass with some speed u. This is before. Then, after that, what happens? After that, what happens? Best example for this, imagine there is a big, fat sumo type of person. Okay, one sumo type of person, very, very strong, very, very big. When small first standard kid comes running towards him, this guy is in college, huge, 6.5 feet person. His mass is only some 150, 130, 170 kg. Huge person, like Khali. It must have happened in some movies also, You would have seen some movies. Very, very tall, very, very huge person. And one small kid, first standard kid. How small are first standard kids? I think this height, or maybe this height. Okay. So I don't know. First standard kids is this height or this height, around this much height. So a small kid comes running towards him. He gets very angry and he's coming here with a speed of 15 meters per second. What do you think will happen after collision? Do you think this guy will even bother? Nothing. He will be like chilling. Oh, what is happening? Nothing. That kid will come, collide elastically and go back, bounce back with the same speed. Yes or no? He will go back with the same speed. Velocity of approach is velocity of separation. Guys, elastic collision. Velocity of approach, velocity of separation, same. So basically this mass will go back with the same speed. This guy will still remain at rest only. Hardly this guy will move. Hardly anything will happen. Understood? So this is the second important thing. Yeah, he will fly back, bounce back with the same speed. Like you take a ball and throw it on a wall. That wall will hardly move. Huge mass. Building is a part, the wall is a part of the building. That ball will come back almost with the same speed. That is exactly this scenario. The next one, the last one, the third one is this, where this is very, very large. This is very, very small. This big mass is coming towards it with speed u. Now just picturize this, guys. That huge Khali-like person, that bodybuilder is coming towards that Pavam guy who is in nursery. Okay, with a speed u. This guy is Pavam at rest. What do you think will happen? This is that huge guy. He's running like this. This is one Pavam guy in nursery. What do you think will happen, guys? Somebody will say, sir, escape velocity, sir. He will fly out of the earth. What will happen? Mar gaya. So what happens is, okay, imagine this guy was moving at 7 meters per second. Do you think this guy's speed will get affected? Do you think this guy's speed will get affected? No, right? He will still continue to move. Hardly any difference. On a small person only. Oh, my speed will still remain 7 only. So what is the speed of approach? What is the approach speed? Isn't it 7? So what should be the separation speed? Shouldn't that be also 7 only? Shouldn't that be also 7 only? So right now he was approaching. Now how to separate him with a speed of 7? Make this guy go with a speed of 14. So 14 minus 7 is 7. Approach speed will be equal to the separation speed. Do you understand? So guys, the final speed of separation will be twice this speed. This will continue with the same speed. Final speed of the smaller mass will be twice the initial speed of the larger mass. That's all. Very, very interesting scenario. So these are some one-dimensional collision, elastic, inelastic, and all these things. So I have laid the foundation of all these things. So after this lecture, when we have PYQ problem solving or more additional problem solving lectures, you will be able to easily solve those problems. Okay, don't worry. This is not the only problems that we are going to do. There will be many problem solving sessions, PYQ sessions, which will be coming in the days to come. Okay. Now, let's go to the next thing. And the next thing is two-dimensional collisions. Two-dimensional collisions. We'll have a PYQ session for both center of mass collisions and rotation, because generally the PYQs are on these three chapters together or mixed problems. We'll be doing it. Okay, don't worry, we'll be definitely having it. Now, whenever collisions in 2D problems are there, there are only two main points I would say to remember. Momentum is conserved. Momentum is conserved in all directions, whether you take x-axis, y-axis, or even 3D, that means z-axis. You take the momentum in x direction, momentum in y direction, momentum in z direction, it is always conserved. Second thing, when you use this value of E, which is separation upon approach, ensure these separation and approach speeds are along the impulse, are always along the impulse. What do I mean by this? You'll understand via problems, but these are the two main things whenever oblique collision or collision in 2D happens. Let's try to solve some questions. Imagine there is a mass going like this with a speed of u, and there is another mass of 2m which is going with a speed of, let's say, 2u. Now, once these masses collide, maybe inelastically or whatever, this mass happens to go like this with a speed of u. This is afterwards. This is before, this is afterwards. So these two come, collide, they go like this. So the question is, what is the speed of 2m? What is the speed of the other mass? Do you see this is a collision in 2D problem? They came like this, dumb, and they went like that. Okay. We know the initial things. We know one of the final things. We need to find the other final thing. Good evening, Rohit, and welcome to the channel. Atma Rama. Yes, welcome. Guys, and if you are new to the channel, make sure you are smashing the subscribe button so that you do not miss this class or this channel, because all amazing content you will get on this channel, that too in English, right? So stay tuned on the channel, and if you are subscribed, you know what to do. Like quickly. Okay, so how to do this question? This is collision in 2D. I can conserve momentum in x also and in y also. If you notice, this is our x-axis, this is our y-axis. So if I conserve the momentum in x-axis and then if I conserve the momentum in y-axis, how will the equations look like? Let me put y over here. Okay, so let's start with x direction momentum. In x direction, only this mass is going initially. So initial momentum is just mu. This mass is going in the vertical direction, so nothing there, is equal to this mass is going in vertical, so there is no x momentum because of this mass. Only this mass can have some x component of the velocity. So 2m into vx. So mm cancels. So won't vx be u by 2? Everybody with me? Okay, awesome. Now this mass may also have some y momentum. Who knows? It's a collision in 2D. We have to assume always the worst of the worst. You can't say best of the best. Always worst of the worst should be assumed and hope for the best, but you always assume the worst. In the y direction, this mass has no momentum. This mass has a momentum of 2m into 2u is equal to, this mass's momentum is mu. This mass's momentum is 2m into vy. M cancels. So this will become 4u is equal to u plus 2vy. So therefore, this will become 3u is equal to 2vy. Therefore, vy is equal to 3 by 2 times of u. Oh, so now I know what must be this guy's total velocity. So the total velocity will be this x component. So u by 2 I cap plus 3u by 2 j cap. That is the final velocity. Got it? How do we solve this? Everyone with me? Shall we proceed ahead? Everyone? Awesome. So let's take an example. Over here. This result is also very interesting. There is a mass which collides, okay, it is coming with some speed u. It collides with a surface over here. It collides with a surface over here. This is the normal drawn to that surface, and it collides with an angle of I. It collides with an angle of I. The coefficient of restitution of that surface is given to be as E. So after the collision, it will reflect like this, maybe with a new speed V, and it will make a new angle R. The question is to find the relation between I and R. The question is find the relation between I and R. That is the question. Angle of incidence and angle of reflection. Yes, we'll be doing rotations soon. Definitely. Saktiral Servan. Yes, definitely. Okay. Now what I will do is, this mass is coming like this and going like that. So on this mass, this surface will apply a force in this direction. Imagine when this mass, when this ball collides with the surface over here, won't it apply a sudden force like this? This will be basically an impulsive force like this. So the force is in this direction, but there is no force in the x direction. So can I say the momentum in the x direction is conserved? But not in the y direction? Because there is no force only in the x direction. When it hits it, there will be a normal force on the ball. So that normal force will change momentum in y. What is there in x? Nothing. No force, no change in momentum. So that's why there is no change in momentum in the x. So if I conserve the momentum in x direction, what will I see? Okay, this mu is like this. This mu is like this. Understand? It will have two components, one component here, one component here. This will be basically I, this will be basically u. This is before. And afterwards, the same mass will be moving like this. One component will be here, one component will be here. This will be r. So think guys, how will the momentum equation look like? Momentum in the x direction, won't it be mu sine of I? Mu sine of I, everyone? Mu's sine component. Here the momentum will be mv sine component of r, angle of reflection. Everyone? Awesome. So now what is the next thing? Cancels. So I'll get u sine I will be v sine of r. V sine of r. Great. Now, this is not all. This is not the relation. I don't know u and v. I don't know u and v. I know e. So what do? I will use coefficient of restitution. And I told you over here, I'll explain what does this mean. Along the impulse, you can use E. Which is the direction of the impulse? Don't you see this is the direction of the impulse? Don't you see this is the direction of the impulse? So only consider speeds along the impulse, means in the y direction in this case. Only consider the velocities, components in the direction of the impulse. So in this case, it is in the y direction. So out of these two components, I will consider this component and this component. Don't worry about this component. Don't worry about this component because it is not along the impulse. So what will be E? Speed of separation. When it hits and goes like that, it is separating with some speed. It is going up. With what speed it is going up? V cos R. V cos R. What is the speed with which it is approaching? What is the speed with which it is approaching? Don't say u. It will be u cos I, this component. So it will be u cos I along the impulse. That is the meaning of it. Clear? Shift it over here. So you will get basically u cos I into E is equal to v cos of R. Take this and divide both of them. Divide both of them. That's all. Take this and basically divide both of them. See what do you get? U sin I by u cos I E. So I think it will be sine of I by E cos I is equal to, here V will get cancelled, sine of R by V cos of R. This will be nothing but tan of I. This will be nothing but tan of I by E is equal to, this is nothing but tan of R. So shift it, you will get E is equal to tan of I divided by tan of R. That is the formula. That is the answer. Check this out. This is so cool. This is like Snell's law. Coefficient of refraction was sin I by sin R, Snell's law. But in mechanics, it becomes coefficient of restitution is tan I by tan R. A very brilliant problem on collision in 2D. Very important that you remember this. Cool? Everyone? Okay. Awesome. Awesome. One last question on collision in 2D, and this will blow your mind. This is only again for elastic oblique collision between identical masses. Okay, very interesting question. So you have a mass m is going with some speed u. The other mass right now also of m is at rest. Just like it happens in carom, you take the striker or a coin, the coin goes like this, tuck, it hits and they go like that. Have you seen that shot? Like a cut shot. You or in a pool table, you take the stick and leave that ball or hit the ball. The ball goes like this, hits something and they go like that. So that kind of a shot. Identical masses, elastic, almost elastic collision only. So you will see that this mass over here will go like this with some speed. And this mass over here will go like this with some other speed. The question is, show that V1 is perpendicular to V2. Show this. Show that velocities are perpendicular to each other. Very brilliant question. This will blow your mind. Many people try to solve this question with such stupid methods and such long methods. They take components, write momentum equation, write velocity of approach is velocity of separation, all those nonsense, multiple equations, use trigonometry, simultaneous equations, solve it, and then you get, yeah, the angles are 90. But I will not do anything like that. Instead, I will use momentum equation in vector form. What is a momentum equation? So conserve the momentum. Conserve the momentum. If I do that, initial momentum is mu bar. U bar could be anything, I cap, j cap, something. Other guy is at rest, so 0 is equal to mv1 bar. It could be in ijk form plus mv2. Simple momentum equation. M gets cancelled. So I will get u bar is v1 bar plus v2 bar. That means if I take a vector v1 and if I take a vector v2, then this vector u is basically the vector sum of vector 1 and vector 2. Agree or disagree? Triangle law of vector addition. If I take v1 and v2, u is the resultant of v1 and v2. Achha. Okay, leave it aside now. Now, clearly it is mentioned elastic. Elastic means E is equal to 1. I'm not going to use separation approach, but I also know initial kinetic will be final kinetic, yes or no. What is the initial kinetic energy? Half mu square. Half mu square. This guy is not even moving. Is equal to these two masses kinetic energy. So half m v1 square plus half m v2 square. Half m cancels. Half m cancels. Correct? So what do you get? You get u square is a v1 square plus a v2 square. Interesting. U square is v1 square plus v2 square. This can only happen if the triangle is a right angled triangle. So hence proved v1 is perpendicular to v2. This is Pythagoras, right? This is Pythagoras, right? Hence proved. Done. Sorted. No complicated maths. Did you love this? Did you love this? What a question, right? So my point is, throughout the chapter, if you noticed, I have taken the pain and effort to show something before and after. That is the most important message. Whenever collision problems or energy problems come, always think of before and after, show it in your rough work. You will not make mistakes. You will understand what to do, when to do, how to do. Okay? You might have to conserve momentum, you might have to use coefficient of restitution, you might have to use energy conservation, or you might have to use some basic common sense that okay, things are moving together, something or the other of that sort. Cool? So I have kept a homework question for all of you. This is from AIMS 2018, very easy. Try to solve it, put it up in the comment section. I want all of your answers in the comment section. And remember guys, in the last moment, Unacademy is trying to help you by giving 25% off on all the NEET UG subscriptions. Okay, on all the NEET UG subscriptions. So if you take basically, you know, a 6-month subscription, you get 2 months free. You get if you take 15 months, you get 4 months free. If you take 6 months, you get 2 months free on Iconic also and Plus also. So all of this at a very affordable rate. You can check out the link which is there in the description box for more details. Make sure that you're using the code CAPTAIN. Make sure you're using the code CAPTAIN to get these price benefits. This is valid only till October 28th. We call this as the unlock. This is a festival offer. A lot of festivities going on. So we want you guys to make the best use of it, especially if you're 2024 aspirants. Till your NEET exam, your entire syllabus, your crash courses, your assignments, your test series, everything is available for you in this subscription. You don't have to enroll into any other thing. And if you're a 11th standard student, even better, you get 4 months free, 15 plus 4. So till the next year and the next year. So you can imagine it's covered, it's done. So your entire thing is covered at 25% off. Even you get the Avenger Batch 3 as a part of the subscription. But if you just want our batch Avenger 3.0, then that link is also there. You can enroll in it. 25% syllabus is remaining. Previous recordings will be available to you. Again, use the code CAPTAIN for getting the best price benefit. This is for NEET 2024 12th standard or the dropper students. Okay, pure English batch, the only best English batch in the country. Okay, so if you got first attempt 320 with 40-day preparation, now I'm targeting 650, but I'm getting motivation and seriousness. Like Gautam, I'll tell you, be with me, stay with me. Just keep your company very good. Keep solving many problems, keep attending lectures. So that's why I say students in my batch, I'll tell you guys, they have changed drastically. Try to attend as many classes of not just me, the entire Avengers team, and make sure that you make a strict plan, make a small tasks and complete those tasks every day. I believe in these last 6 months, you can achieve 650 plus easily if you have got 300, 400 marks. Take it, don't worry about it. You can definitely improve. Point is, you have to be very systematic, you have to be patient, you have to make small tasks, achieve those tasks, you have to be very regular in attending those live batches, give tests, analyze mistakes, and practice. That's the key. Okay, so I'll see you guys soon. Next chapter, we'll try to do rotation. We'll also do ray optics and all of that. Okay, so stay tuned on the channel. Hopefully you have liked the video and comment the answer of the homework down after the video ends. This is Captain Shreyas signing off guys. Hasta la vista.